Now I will bevel the corners and break the corners and smooth this off a little bit. Then the base is done. And this is what it looks like so far. Next I will unbolt it again, unscrew it, and I will lay out the hole for the main shaft, which is 7/8 from the bottom, and then the next hole for the pivot point will be 2 1/16 from that. I've done the layout. The bottom hole here is, that's the bottom, 7/8 up from the bottom, and then the pivot hole here is 2 1/16 up from that hole, and that's to be a 7/32 hole, that's to be an 1/8 inch hole, and then it'll be counterbored from the back side. I will do all of that off camera. Okay, this is the 1/8 inch hole for the pivot point, and I've counterboarded on the back side 1/4 inch for the spring, and that's about a 1/4 inch deep approximately. And the idea here is this little brass bushing made from this hobby brass, which is 7/32 OD and 3/16 ID, and if you don't have any of that, you can make yourself a brass bushing just so it has a 3/16 ID. You can go with any OD you want. That's going to be a little bit of a tight fit, but that's going to be pushed in there and held in with Loctite if necessary. Let me talk about these flywheels here. These are lead flywheels, but I use lead that was used by printers. They call it type lead. Some of you don't even know what that is anymore, but it's a hard lead. It had antimony in it, and sometimes I use wheel weights. That's got some antimony in it also. That doesn't make it so dead soft. But years ago when I was in my prime, I made these molds here, permanent molds, and I had them in 2 different sizes. And this particular flywheel is about, well, it was 3 1/4 to start with. This one has been machined. I don't have any rough cast ones to show you here. But then I decided I needed a smaller version, so I came up with this one, and that's about 2 1/2 with a thicker rim on it. And it's just like pouring sinkers. That's what it looks like when it comes out of the mold. I have to do that out in my garage. I haven't made any of these in a long time. That's why I make a big batch of them when I do make them. But here's how this works. Just like a sinker mold, 2 halves with alignment pins, and if I can find it here, this is a tapered dowel pin or a tapered pin, and when I put this in there like that, it only goes in one way. I guess that's why it says small and large. I must have done that a long time ago. And I hold this in a vise when I pour the lead in there. I have to preheat this. But when I'm done, and I'm going to open it up, and it just takes a minute before it hardens, I tap the pin out, and it drops out because it's tapered. And when I take the casting out of there, the hole is already formed. Now it has to be reamed, so I just run a 3/16 reamer through there, and doesn't take much to clean it out, and it's ready to go. And I can mount it, I can put a set screw hole in there. Now the other reason I put the hole in there, there's a great tendency for shrinkage in a thick spot, so I suffered with that until I decided I needed to cast the axle hole in there. I got a little carried away there talking about flywheels, but the lead gives it the inertia that I like. And this one has been machined down to reduce the thickness of the rim. That's what they look like as cast. So this is difficult material to machine, even though it's soft, because it does tend to chatter like crazy. I think because I'm only holding it on a 3/16 arbor. So this is going to be my main shaft, and that'll fit in there like that. And then in this particular one, I've already there's the set screw. Couldn't find the set screw hole. I already got a set screw in there, drilled and tapped, and that's a real small one. I think it's a 440. So I will now make the main shaft, and since you're not going to be able to do this, and I have none of these for sale, go ahead and make yourself about a 2-inch flywheel out of steel, 1/2 inch thick approximately, with the set screw like I showed you in the other video. But my flywheel will look like this. So now I'm going to go ahead and make the main shaft, and then I'm going to make the crank here. And I'm going to go back to just a straight round one like this, because believe it or not, this little counterbalance business here, I like the appearance of it. I doubt if it has any effect at all in balancing it. And it's kind of a pain in the neck to make, as it's intricate, and you can fiddle around working on that thing for 45 minutes. So I'm just going to make a plain one like this. This material is for the crank pin, aluminum, and I didn't have any 1 1/8 diameter, so I'm turning it down. I got one more pass. I've already faced it, drilled it, and reamed it 3/16. Cutting it off about 1/4 inch thick. Now is a good time to chamfer both corners. Be very careful when filing on the lathe. Make sure you have a handle and keep your left elbow up high. So I'll finish cutting that off. That's the front side of the crank disc, and of course this is the side that I cut off, so it's going to get machined. But the way I like to do that is I'm going to go ahead and Loctite the 3/16 shaft onto there, and then let that set for a while I'm doing other things, and then when that is set, I will put it back in the lathe and face off this side, and then drill the hole for the crank pin. To speed up the setting, I usually set this on the warm furnace ducts. Okay, an hour or two has passed and the Loctite has set, and now I'm going to put it in the 3-jaw and face this off smooth, and then get ready to do my layout for the crank pin. Now if you do not want to use Loctite, you can also use a set screw to hold that on, or pin it, or you can thread the end of the shaft and tap the aluminum disc here. But then you probably also need to use Loctite on it so that at some point that doesn't unscrew. I like this solution. Now I've got this faced off, and in order to lay it off, or lay it out, I'm just going to use my center finder here and draw a line. Doesn't need to go all the way across, but I think I will anyway. So there we got a center line on the work. And the little depth finder here is set at 3/16 of an inch. Now if you do the math, the distance from the end of this little ruler to the center of the work is 3/8. That's how I came up with the 3/16. That gives us a 3/8 throw, double that for a 3/4 inch stroke. Now I will center punch this and drill it 1/8 inch off camera. I sawed off some 1/8 inch rod. It's steel, It's 9/16 long. By the way, this is a handy way to hold small pieces like this when you have to grind or sand them. Keeps your fingers away from the wheels. It's kind of hard to hang on to some of these real little pieces, and they get so hot. Now it's ready to Loctite in place. Then I'm quitting for the day. Been a long day. And if there isn't any Loctite showing on the back side here, get a little bit in there. It just takes a drop. Remember now, any Loctite that is on the outside and not in the absence of oxygen will not set up. So it's the stuff on the inside that is going to harden or cure, whatever the word is. And if you need to get any of these parts disassembled at some point, it's easy enough to do by heating with your mini torch, and they will pull apart, and you're going to find that there is a white residue on there, and that can be machined off or taken off with emery cloth and then reassembled as necessary. But you can get this type of Loctite apart with heat. Hello again, it's a new day and in January here in northern Illinois, and it is so cold outside that the snow squeaks, and it's a good time to be in my nice warm basement workshop. So let's get to work again. Now I've got the flywheel and the crank mounted here, at least temporarily. Now this is way too long, and that will be trimmed later on when I determine how much distance I need right in here. And so far this is just a press fit with the brass sleeve here, but this might have to move in a little bit, and then I will trim that. Now I want to turn my attention to the cylinder. That's the hardest part of this engine. So on the prototype here, I've taken the head off, and it only has 2 screws. I told you I'm going to have 4 screws. And the reason for the orientation like this, rather than having the hole straight in, is that we do not want this hole to interfere with the one of the steam ports right there. You can see how close that is to the top. The other side of the head has a recess to help it get centered and so on. And this little ring on the top here is strictly ornamental. I may not do that on the new one. This is a 5/8 bore. Now I'm going to change the bore to 9/16 on the new one, and the reason for that is that the walls here are so thin that I'm dangerously close with the screws to the cylinder bore. And for you newbies that haven't done much of this, that's really something you want to avoid, because it'll be very discouraging if you break into the cylinder. My cylinder is being made of this 1-inch thick, 2-inch wide aluminum. That came from the scrapyard. I have no idea what alloy is. I guess there's some numbers on there, but it doesn't make any difference to me. And I've already cut off a piece that is 1 inch long. And I've taken a little bit off of the length of it, and later on I think this is probably going to be reduced a little bit in length too, but I just soon have that extra long to start with. And then I can determine what the total stroke is and any adjustments I have to make. Now notice on the prototype here that when the piston comes up, I have really some distance yet to that port, so the entire cylinder could be even shorter than what I show here. But it's kind of irrelevant other than the appearance of it. When you use your surface plate and your height gauge, make sure that it is cleaned constantly with your hand, and you can feel any grit or chips. Same thing with the bottom of your height gauge. It must be clean, and the surface of the work needs to be clean. And for instance, let's put this surface down, just strike it with a file to make sure there's no burrs or high spots. Wipe it off. All these little details here are important. Now it is ready to put on the surface plate, and we know that it's truly sitting there flat. And I've set the height gauge for 500 thousandths. And there is the location of the center of the bore. If you recall, the single acting engine that I made is headless, so it's a blind hole. But this hole is going to go all the way through, and I laid that out with the dividers, and since it's 9/16 diameter, the radius was 9/32, so I just swung that around there. It isn't really necessary since I'm going to do this on the milling machine. And I put the circle on there mainly to show you the location of the hole, and that it's longer. We got more surface or depth right here because that's where the pivot point is going to be. And there's plenty of room around it now for screw holes. And the original one now, again, was bored on the lathe. I'm going to use the Bridgeport mill, and there's more than one way to do this. I'm going to drill it and ream it, and if I'm not satisfied with the surface finish of the reamer, and it's a used reamer, so no telling what I'm going to get, I will go in there with the boring bar and the boring head and clean it up. And the final diameter, as long as it's around 9/16, really doesn't matter too much, because I always like to make the piston to fit the bore. On the other one, since it was a 5/8 bore on the prototype, I happen to have one of these dingleberry hones, and I had cleaned up real nice, but that is not going to fit into the 9/16 hole. It's more like 5/8 or a little bit over. Matter of fact, it was kind of a force fit into that bore. Let's step over to the Bridgeport mill. Before I begin a job like this, I like to lay out my cutting tools to make sure that I truly have everything that I need. That is, I'm going to go in with a center drill and then a 1/4 inch as a pilot, and then this bit here is a 17/32, and it's a straight shank with a 1/2 inch shank here. So, and it's short. Try to avoid those real long bits, because then you got to drop the table so terribly much. Well, look what happened here. This is a 9/16 chucking reamer, but it's very, very long. So I will not hold that in the chuck. I will hold it directly in a 7/16 collet. Again, so I don't have to crank my head off getting the table up and down. The work is in the vise, and it's not setting on the bottom of the vise. It's raised up about a 1/2 inch, so I won't strike the vise with any of the cutting tools. And I double checked the squareness this way with my little Lufkin square to make sure that I'm square, because I was uncertain how square the bottom of the stock was. So I want to make sure that the hole goes in straight. There's all kinds of ways of locating the work on center with the spindle. Now you can use a digital readout, come in with an edge finder of some kind or a wiggler, you know, and locate the edge, and then move in 500 thousandths by 500 thousandths with watching the digital readout. Or if you don't have one of those, this is a wiggler with the sharp point. So that's what I'm going to use, just to locate it as if it's a scriber. I've had this wiggler for years, and they come with different attachments on the end, and this is the scriber, the pointy end. Now when I turn the machine on, it's going to wobble like crazy, and I will true it up just with any tool. This is just the shank of a bit. Don't put your finger in there, because sometimes they swing around, do crazy things. And so this is all this to it. See how it wiggles? And when you do this, it will quickly true up. I'm going to bring it in to the approximate position. We still got a little bit of a wiggle to it, so I'm just going to true it. There. Now, wearing my glasses, my optivisor, which is mandatory if you're over 40. And using the X and Y axis, I can get it very close to my center punch or my bullseye mark right in the center. Then I will lock the table in the X and the Y axis, and I'm going to set my digital readout for 0 in both axes, 0, 0, 0, so that if I need to move the table one way or the other to change the tooling, I can, and then I don't have to drop the table, and that's perfectly accurate for a job like this. This is my favorite Jacob's chuck because it has a straight shank on it, and I hold it in a 3/4 R8 collet rather than changing the whole spindle. It does not have the R8 shank, but that'll work too. But my R8 chuck is a huge one. It's I think a 5/8 capacity. I like the smaller one. And I've got a center drill mounted in there, table locked. I'm drilling using the quill feed as if it was a drill press rather than raising the knee. That's my preferred method, but some of you might be using benchtop mills, so then you'll have to, well, I'm not sure what you do with a benchtop mill, but this is my pilot hole, 1/4 inch all the way through.